Hey everybody. Thanks for attending this presentation. I'm going to present you T-Minus Engineering. That's a company that builds, designs and operates rockets. We started quite a while back. The idea came when we were in a van. We just finished with a group of amateur rocketeers, finished a big project which we launched on a professional launch site in the top of Sweden. And we thought, okay, we have a multidisciplinary team, a lot of people here, and we all cooperate very well together. Let's keep this team, let's not disperse over industry, let's build a company that does rocketry. So our first project was done for a contract that we won by the European Space Agency. It was the CanSat launcher. It deploys 6 small pseudo-satellites at 1 kilometer altitude, and that's mainly used for educational purposes. And we figured, okay, let's bring this a step further. So we came up with this concept. It's a T-minus DART. It's a system which you can really cost-effectively bring a payload to 120 kilometers altitude. We saw sounding rockets on the professional launch site. They were big, they were bulky, and they were very cumbersome to operate. We thought this can be done better. Make it easier to operate, make assembly easier. So we bring down the operation time that's normally done with a group of 10 people for 2 weeks, bring it down with a crew of just 2 people in half an hour. And this enables a lot of possibilities. And next to that, it brings down the operational cost by a 10-fold. So it's really cost effective and really user friendly. Well, our main users, as we see it now, the main targeted users are scientists that perform measurements in the middle atmosphere up to 120 kilometers altitude. This region we call also the ignorasphere because it's very hard to actually get there. If you go with a stratospheric balloon, that only goes up to 30 kilometers. And a satellite, of course, burns up at 120 kilometers because there's too much air over there. So the sounding rocket is the only way to get there. And by making this efficiently, we can enable real science, real in situ measurements in this region. So scientists are really happy to see this coming. We have letters of intent showing that we can at least initially do 15 launches per year. And in the end, our market studies show that we can grow to 80 launches per year in Europe only. And this represents a turnover of at least 5 million per year. So, of course, the development, we're still in development. Qualification, we still have to perform a bit of that. For that, of course, the whole development costs money. I mean, we can't afford to work for free. So, the other branch of our company does support, engineering support and consultancy. With this, for example, we have a big contract here with DLR to work on a NASA mission to Mars inside. We did that for the last couple of years. We gained a lot of knowledge, and of course it provided the financial influx to provide us with the development means that we need. So that's T-minus engineering. Hands-on, we're posing on the launcher, the mobile launcher that we have here. It's a launch infrastructure that shows we don't only design, we're not only engineers, no, we know how to operate this stuff. We know from the start to finish what sounding rockets are and how they can be optimized. So this really is the strength of our company. I still have a minute left, but my pitch is over, so thanks a lot for your attention. And of course, I'm very happy to answer any questions that you might have, the jury. Please go ahead.
All right, thank you for your presentation. It's great to see people from my own town as well. It's Delft representative here. The thing I wanted to talk about a little bit is scalability of the product. Not only about the market, which is mainly institutional, it's something we discussed before already, but also launching capacity, because you're talking about a mobile launching opportunity here. So is that something that differentiates you from other parties as well, that you are capable of launching everywhere in the world?
Absolutely, yeah. This launcher is fully mobile. We can transport it by road everywhere in Europe. So this is truly unique. And of course, you can see that it works for a small system very well. And as soon as the system becomes bigger, it gets more complicated. You need military precision to make an operation like this. So scalability you see here also has an added benefit. Scaling it up, of course, we see that certain payloads need to be bigger. Once we have the infrastructure for a small sounding rockets there, the whole supply chain will be there. Propellant manufacturing, we have good contacts with a company that does that. It's a specialism that we don't have at the moment. Once the whole supply chain is there, we can easily scale it up. These sounding rockets are very, very scalable. So going to bigger payloads, right now they're launched with military surplus motors. So that's highly, well, non-optimal. And we can do it in an optimal way. And so we see definitely some future there. But first we focus on really making this product a success. We get responses from the community that this is really something, a product that they are looking for. So this we really want to fix first. Does that answer the question?
Yeah, thank you.
Okay, perfect.
Great presentation.
Thanks.
So I work for NASA. So I get really excited when I see smoke and fire.
You're not the only one. Then.
So having said that, it's good to hear that you have a scalable product here. But what I more so want to understand is, you know, what type of assessments have you done so far, identifying your target market? How are you differentiating yourself, your company, from your competition who are, you know, looking to do the same thing with their sounding rockets, you know, placing small payloads, CubeSats, you know, what have you, into orbit?
Okay, yeah, maybe first I have to clarify this a little bit. This is a sounding rocket. It doesn't go to orbit. It goes into the atmosphere, make the measurements in situ, so really there at the place where it is, and then it comes down. So that's already a bit different than the orbital launchers. And also a thing that's really different, I mean, a sounding rocket still, I mean, a rocket in general, is a very complex system. So you need a very multidisciplinary team to make this happen, to make this work. You need electronic engineers, you need propulsion engineers, I'm one of them, structural engineers, also operational engineers. Well, we, with a small company, have all this knowledge in-house because we have a great heritage in sounding rockets. And we know the people, we talk to the customers and to the operators of other sounding rockets, and we see the things that go wrong and that could be improved. And this is the big strength of our company. So bringing together all this knowledge in one single house, that's really how we differentiate from other parties.